Hey guys, and welcome back to the channel. Today we're gonna do Advent of Code 2015, day 11. We'll do it a bit differently today because there are several ways how you could solve it. I'll show you first one without coding, the next one with coding, and I'll show you two options how to solve it in Swift. They're basically the same, they're just using different techniques. Now let's head over to the problem description. Okay, so day 11. Apparently, Santa has the same problems that we have and he needs to use a new password. I think back in 2015 it was still alright to always change the passwords instead of just using password managers and auto-generate them. So he needed to find a new password. There are several rules a password needs to follow. So it must include one increasing straight of 3 letters. So for example, FGH, something like that. And they can't skip any letter in between. I, O, and L are forbidden, and there must be 2 overlapping pairs. So we already had that overlapping pair thing a couple of days ago. We could just brute force it, go through our characters, and then find the next matching one. There's also one solution that's actually a bit nicer. So my input was CQJXJNDS. Now the first rule is increasing. So for example, A, B, C. So X is the last letter that can form such a sequence, and then we'll wrap around and we have A, B, C, all of those can start sequences again. And we need to have 2 non-overlapping pairs. So you can see there's no overlapping pair in there, so we need to form one. Since we start at the end of the string and change the characters at the end, those overlapping pairs will be at the end again. What we basically are looking for is something like A, B, C, C. Because then we have A, B, C in there, and we have AA and CC. So those characters will be the last 5. And our last 5 characters are X, J, N, D, S. And looking at that, we see the first character we have is an X. And X can actually start a sequence like that, which is X, X, Y, Z, Z. And with that, we already solved our problem. So the next password is C, Q, J, X, X, Y, Z, Z. XX and CC are the doubles, XYC is the other thing, and it doesn't contain I, O, and L, although my J probably looks like an I. So that's how to solve that problem with reasoning. And once we're here, let's just quickly look at how to solve day 2. So day 2, password expired again. What's the next one? So we need to take that password and do the same thing again. Doing our same reasoning, we now have XX, Y, Z, Z as our last 5 letters. The next one will be X, X, Z, A, A. And those will never be able to form the sequence we need. So we need to wrap over the next character, which is J. So J will be K. Now what we have is K. Now remember, if we wrap over, it means those will all be A, 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 A. And the next possible sequence we can have is A, A, B, C, C. That's the sequence we can generate. So our next password is C, Q, K, A, B, C, C. So that's part 1 and part 2 solved without coding anything. I didn't come up with the solution. It's just interesting to think about it. So let's quickly jump over to the code. So one thing you can't do in Swift is to add characters together. So let's say A plus 1 would be B. That doesn't work in Swift. You always need to get the ASCII value of a character, and then you have a uint8 with the ASCII value. So first I converted my input to ASCII values, calculate the next number, which we'll look into in a minute, and I repeat that until the new numbers are the initial numbers. So that's just to make sure that I don't run to an infinite loop. So if we found a password that actually works, we will break early. It's just to make sure if we did something wrong, the program will finish at some point. Then I check whether my new sequence is valid. If it is, I will go through each ASCII value, have it back as a character again, and then convert that character array to a string, print it, and then I get my result. Okay, so let's look how to generate the next number. So the problem with generating those sequences is you always need to wrap around. If you're at Z, the next one is A, but you need to wrap around the one before. I did it with some kind of recursion. So what we first do is we get the sequence, then we pop last. Let's quickly think about it again. If we have ABC, that will lead to AB remaining in new. The next will first be C, then we add 1, which will basically lead to next being D. So just remember we have AB in new and we have D in our next. And now we check is next, which is currently D, bigger than Z, which will then lead to wrapping around. So if it's not bigger than C, we just return new plus next. So basically return AB plus D, which is our next sequence after ABC. Now if we have AB Z, for example, next will be Z, and then Z plus 1, which is bigger than 1. What happens now is we go into that part. So we take AB and do the same thing we did before. So we call it with AB. We will have A and B, increment B, which will be A and C. So that part will be AC. We will add A to it. We will have ACA, which is the value we want to have after A, B, and Z. Now, one minor thing I did is improving our performance a bit. So every time we encounter I, O, or U, they are forbidden values and we don't need to calculate anything having them. So if we have, for example, AAI, we can just skip over to J because that will never be valid. We don't need to do anything. And if it's the last character, you don't have any speed up actually because it's just one iteration. But the major speed up happens if you, for example, take something like that and you come to I. What that actually does is it replaces the I with J and skips every possible combination starting with AAI. So there are a lot of cases you are skipping. And now the only thing left is valid. So first say doesn't have an increasing value and we don't have any duplicates found. And I remember the last duplicate I found. So that's to make sure that we filter out overlapping doubles. If you're interested in how that actually works and why it's working, you can just watch my day 5 video because at day 5 we also had the same problem with those overlapping duplicates. And now we'll just iterate over the sequence. Since we always check the current index and the next one, we need to make sure that the next one is actually valid. First, I check whether we have some duplicates. If the next value is equal to that value and we didn't match it prior to it, we can increase our duplicate count and store the index that we used as a duplicate. So that's to make sure that they don't overlap. And now we just need to check for the increasing sequence. And for the increasing sequence, we need to make sure that there are actually 3 characters. If not, we can just skip. And then what we actually make sure is that they are increasing. So the first one plus 1 is the next one, and the next one plus 1 is the second to next one. If that's the case, we set has increasing to true. And after calculating all of that, we just say has increasing and duplicate count bigger than 2. Just return it. Okay, so those were my solutions for day 11. I hope you learned something or at least found it entertaining, and see you at day 12.